And hello there folks, this is your Uncle Troy. Today we are playing Minecraft Feed the Beast Minecraft Edition, and we are working on the automated tree farm and charcoal factory. And I just hit the wrong button. There we go. Okay, so today we're going to go over the code that I wrote to cause the turtle to cut down these trees and make some improvement in the charcoal producing part of the factory. The iron furnace does not work quite as fast as I thought it would, and the wood comes in a lot faster than I thought it would. So we're going to have to do some changes here. Probably multiple furnaces. I tried a little experiment over here to see if a single redstone engine and a single wooden transport pipe would transport out of multiple furnaces, furnace, and it turns out it will not. However, if you use the wrench and change the wooden transport pipe, you can. So I'd have to end up sending a I'd end up having to send a redstone signal to this pipe every so often to get it to change, and that will be kind of inconvenient. So we're going to be redoing all this. But first, we're going to go line by line through this turtle program. Now, I have called this program Tree Farm, and we're going to go through it line by line, as I said, and explain everything. Okay, so the lines that start with the double dashes are comments that this is a tree farm tending turtle, cuts down and retransfer fir trees, and we're going to assign some variables. And actually, we don't really do much in variables, but we're going to go anyway. All right, first thing we do is turtle select 1. And that selects this first slot here. That's where I keep the fuel in most of my scripts, so that's why that's there. Then local targs, turtle arguments. This is a ... And that's a special thing, so when you type in a command, turtle whatever the name of the program, and arguments, ... is the arguments. Local, oh by the way, local just means that this variable or procedure or whatever is used in this program or in this function or whatever, not in other programs. Local to go, and actually, this is left over from another program, doesn't really apply here, but toNumber converts anything in the parentheses here into a number. So if there is an argument in this thing, it's converted to a number. And then we say if the number doesn't exist, or is 0, well, we want the number or 1, and so it goes to 1. And that is also left over from another program, so ignore that. Now this one we do need. Local sapling equals 0. We're going to assume there are no saplings over here in slot 2. We'll change that if it turns out we're wrong. Term clear just clears the terminal. Term set cursor position sets the position to 1, 1, which is up here in this corner because it starts counting from here. And then we're going to print OS_get computer label. That's just a simple way of figuring out, or having the turtle know what it's called at your service. And the print command simply prints that. So then the print commands fill out basically what we're supposed to do. We're supposed to place blocks as follows. Slot 1, fuel, as we have done. Slot 2, saplings, as we have done. Place the turtle over the chest at the edge of the farm, which we've done, and press enter when ready. And then read input waits for you to type something and end it with hitting enter or return. So far so good. We've not done a whole lot. Now we're getting into good stuff. Okay. If turtle get item count 1, which is basically in the turtle, look at slot 1, which is what we was thinking here, and get the item count. How many is in here? In this case, it's 61. Now if that is less than 1, which would mean it's 0, then we're going to print no fuel, abort, and we're going to quit. And actually this quit command does not work. Instead it throws up an error. but the error also ends the program, so that's as good as quitting. So I've never figured out how to go past that. And this end here basically matches up with this if statement. If something is true, then do this, and here's the end of it. Then you go to the next line. We said sapling equals 0, and actually we set that before, but we're setting it again because I'm a very bad programmer. Now, if turtle get item count 2, which means get the item count of the number of things in the second position, is greater than 0, meaning there is something here, then we're going to set sapling to 1. We could have set that to sapling is true or sapling is yes, but I just chose 1. That'll come in handy later. Now we define some functions, which I'm going to skip through. I wish the page down would work to get to the main loop of the program. Skipping, 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 skip to the loo, my darling. Alright, to the main loop. So first, I have created a special function called turtle forward, T forward, and told it 2. So we're going to move into the first position by, let me back out of this for a second. As you can see, he's got about 2 spaces before he butts up against this wall here. So that's why he's moving forward, starting with 2. Then he's going to cut this tree, then he's going to move forward to the next. Oh, disregard the funny tree out here. He kind of dug half a tree at one point, and I had to fill it in, so he'd work right later. He's going to move forward. Then he's going to do some really weird multiple stuff. Basically, the trees here are aligned in a 4x4 grid. So he's going to repeat this loop 4 times, 1 to 4, do. Then inside that loop, he's going to repeat this loop 4 times. And that's going to be 1 loop to get him down each in a row, and then the inside loop is to go to each tree in the row. And basically, if he's inside the loop, he's going to move forward a couple he's going to, like I said, he moved forward until he was up against the first tree. Then he's going to climb the tree, which we will go into detail later. And then if he's not at the end of the row, he's going to move forward a couple times. Now, if he is at the end of the row, he won't move forward. And then here's the magic part. And by magic, I mean you're not expected to understand this. If our row mod 2, which is divide row by 2 and take the remainder, is greater than 0, meaning we're on an we're on an odd row. You know, the first row or the first row or the third row. Then we're going to turn right. When we get to the end of this row, tick, 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 we're going to turn right. When we get to the end of this row, tick, 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 we got to turn left. Tick, 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 turn right. Tick, 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 turn left. Actually, if we were continuing on out here. So this is some fancy math to when we get down to the end of this row, how far over we have to go to be in the right position to dig going back. And that was some trial and error and some common sense, and I don't expect you to understand that, but that is how it goes. So basically at the end of the row, we're going to turn right, go over a certain number, follow this row, then we're going to turn left, and because we're lined up different, we're going to go a slightly smaller amount, follow this row, turn right, the longer amount, turn right. And then at the end, after we've done all the trees, well, then we're going to turn right, and we're going to do some forwards and some lefts to move down here, back over this chest where we started, and reload some saplings. We're going to choose the saplings, and we're going to suck from the turtle suck down, picks up any loose items or anything in the container underneath it, and we're going to suck up an entire row, which will probably, since we'll have less than a full stack here at some point, picking up a full stack, we'll fill this one up, and we'll probably have some extras over here. So then we're going to select the third slot, and we're going to drop the extras. So if we had, for example, at the end of the run, we had like 36 saplings, we would pick up 64. That would fill this slot, but we'd have some extras over here, so we'd drop them back down in the chest. And at that point, we're done. We're at the end. Now, a lot of that is kind of confusing, but I'm going to put this program up for download so you can go through it step by step. Now, let's go back up here to where we start defining all our functions. Alright, the first function we got is tfuel, turtle fuel. And this is called by some of our move functions, this tforward and whatnot. So it gets called fairly often. And what it does is it gets the turtle's fuel level. And if that is less than 16, meaning we don't have enough space, enough energy to go more than 16 more spaces, and that's kind of an arbitrary amount, then we're going to turtle select 1 and we're going to refuel by the amount given. I think I usually give this a 1 just to refill one fuel unit at a time. Now I could refuel 10 or 20 or 100, or well, probably not more than 64 because that's as much as we can have in a stack. But if you refuel, call it regularly, then the turtle never runs out of fuel. Now here is local function tforward, which was a custom thing I did to put the turtle forward a certain amount. Now it takes steps as an argument. And here I've tried to explain that if the steps is nil, meaning we didn't get an argument, or the steps is 0, then steps is going to be equal to, let's scroll out here, 1 n. So basically if you give it no argument when you call tforward, it will assume you wanted to go ahead one step. And this should be written something like this, with everything on its own line. But when you have a short thing like this, you can stick it all together. And as I said, this function immediately calls tfuel just to make sure. Now, for I equals 1 to steps do, that means it's going to take I and it will go from number 1 to whatever steps turns out to be in increments of 1, and for each of those it will do these things. So while not turtle forward do something like that. Yes, there we go. The indentation is not necessary, but if you do indent it like this, it's easier to follow. So this is our for loop from this to this. This is our while loop. So turtle forward is a command that tells the turtle to move one step forward. If it succeeds, it returns true. If it fails, it returns false. For example, let's exit out of this for a second. Alright, we are currently sitting here, and it's dark again, but I think I've turned off mobs, or turned to peaceful mode. So if we go into the Lua interpreter, we can say turtle.forward. Sheesh. That didn't work. Let's try that again. Turtle forward. And it returns true. And you can also see it has moved one step forward. So we can say turtle back. Apparently the closed parentheses is assigned to something that I'm not familiar with. Again, it says true. Now if we stand directly behind this thing and we say turtle back, it says false because it could not move backwards because we were standing in front of it. And let's go back to editing tree farm. When it encounters turtle forward, it tries to move forward, and if it's successful, it returns true. So, but the not here reverses that. So basically we're saying while we're not successful, do what's in this loop. And what this loop does is it tries to dig, and it also tries to attack. So suppose we're going from tree to tree here, and maybe some leaves have grown down here low, like you can see they've grown there. Or perhaps there's a monster somewhere in here, a bat has wandered in. Then this tells you to either, well, both try to dig and then try to attack. And to keep doing that over and over again until you can actually move forward. And that's pretty much all there is to it. The rest of it's ends that close out these statements. So basically all this does is reads the number of steps it's supposed to go forward, checks the fuel, and then does that, taking the time to dig or attack anything that gets in the way. And I would end up, since I'm trying to make this turtle program fairly robust, R-O-B-U-S-T, robust, which means it's not easily, standing in front of it doesn't stop it. Unexpected input, that's what I was trying to say. Unexpected input doesn't cause the program to mess up. So that's why we do this every time we're going to be moving forward. Okay. Local function turnaround, I'm not even sure I use this, but it just turns right twice so you're pointed back the way you were. Alright, local function discard. Drop off your excess stuff. This gets called when it's time to get rid of the items in the turtle's inventory. Now if turtle get item count 3, which would be this slot here, is less than 1, then we just return. And this just means exit out of this function and go back to where we were. And that's because we're going to be dropping the items in slots 3 through 16, and if there's nothing here, we'll assume the rest of them are empty and we can just quit. Alright, so next is a very simple, wants to go down one space, and if there's something blocking us, we're going to try to dig. And that is so when we get to the end of a row, say here, or an end of things, we can drop down one space so we know when we drop stuff it will end up in the water and not hung on a ledge somewhere. Alright, so then we're going to cycle through the I equals 3 to 16, which means we're going to go through this one after the other. Slot 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, blah, blah. I keep trying to move with the cursor, or with the, that didn't work. I keep trying to move with the mouse, getting confused and messing things up. There we go. Now it's indented a little better. And basically what it's going to say is, for each slot in which we have more than 0 items, we're going to select that slot and we're going to drop in the down position, which should drop it in the water down there. Then we're going to move one space up, and just in case something has fallen on top of us, we're going to try to dig up until we can. Then we're going to say turtle select 1, so that the turtle's acting on slot 1 again. Now the reason we're doing that is that if the turtle has slot 1 selected and we dig something identical to slot 1, it will get put in slot 1. If we had slot 3 selected and we dug more fir logs, they would end up here and then they would go on down. And since we're constantly fueling from slot 1, we want to make sure that this is always topped off with fir logs. Now local function climb. This is where we actually start digging the tree, or chopping down the tree, however you want to put it. Now turtle detect simply means, is there a block in front of me? So as previously stated, we start by moving forward a couple spaces so we're butted up against this tree. Now if however the tree has not grown, then there will be saplings down here and this will be empty space. But if it does detect something, that's going to dig and then move forward one slot to put it inside the tree. Then it's going to start counting, and as it counts it's going to be going up. The sleeps kind of help with the lag a little. It's going to dig forward, dig above, double check to make sure it doesn't need any fuel, and then it's going to move up. And it's going to keep doing that until it does not detect a block in front of it. Well, then it's going to turn right and move forward. It's going to turn left, and then it's going to dig back down using the same count that it's been keeping track of here. It's going to dig down, sleep for half a second, check its fuel, dig down, or move down, dig forward, keep going. Now at the very end, by this end point, it has finished digging out the tree. And then what it's going to do is, as you know, we're one layer away from the actual bottom of the tree. So what he's going to do is he's going to dig down underneath them. He's going to select slot 2, which is here, and he's going to place one of them. Then he's going to do a little dance which I could have done more effectively, probably with some for loops or whatnot. But basically, he just moves to all the different spaces in the tree and digs up that last stump and plants the firs. Then he turns around and moves forward 2 spaces. So he starts here, he works his way up, works his way back down, then he digs all these out, plants the saplings, and then he moves forward to where he's facing up against the next tree. Or, and this else is with an if statement way up here, where it said, did you detect something? And if he doesn't detect something, then he just moves forward 3 spaces to get to the next tree. And then when all that's done, he does the discard function we mentioned before, where he drops down and drops everything off. And now that we've kind of explained that, let's just actually do it. And now it prints the things. It identifies itself as nephew, prints what you're supposed to have in the slots, says press enter when ready. So he goes off and he starts digging. Like I said, he goes up against the tree, starts working his way up. My frame rate starts to drop, and I thought it had something to do with the turtle, but actually has something to do with all these fir trees. The leaf blocks, once they start decaying, really eat up the processing time. And of course, there's a whole lot of leaves here. Whole lot of leaves here, leaves. Whole lot of the plural of leaf here. So I have set it down to fast graphics instead of fancy graphics, and I have set it to I think normal render distance instead of far, and I get pretty good frame rates. I'll probably have to try this with jungle saplings or maybe redwood and see if it works as well. And as you can see, the tree's leaves are despawning. We should see saplings falling anytime now. And I think I hear the turtle coming back down. Yes, I do. And hopefully we'll see it here shortly. There we are. And as you can see, he's digging back down the other side. When he gets down to the bottom, he will replant, hopefully. Then he will drop off his extra stuff. And then he'll go forward. And I hope I filled in all those, because what had happened was I had stopped him on his way up before, and I forgot to fill everything in. So every time after that, he would go to that point, think he had went all the way up to the top, cut over, back down, replant, and go. And actually, when he gets down there, he will dig those saplings up and immediately replant them. But that's because that's one of those robust things that I needed to work on. And once again, we have run long, so tune in next time for the hopefully conclusion of this little tutorial. This is Uncle Troy signing out. Please have a good night.